Hello, everyone. Can you hear me okay? Well, so nice to see so many faces from around the world. This is the second of CS50's New Year seminars. This one focused on a language called SQL, which is incredibly popular for the use of databases and storage of data therein. In a moment, I'll introduce today's teacher, CS50's own Brian Yu. But if you're new to CS50, this is indeed just a taste. CS50 is Harvard's introduction to the intellectual enterprises of computer science and the art of programming. And one of the languages we look at in that class towards semester's end is precisely today's language, SQL, as we introduce students to the world of web programming and databases. We're thrilled to say that for these New Year's seminars, we've had over 10,000 registrants from around the world. Indeed, if you haven't already, please feel free to say hello to everyone around the world in the chat window and where you yourself are from. And we also are fortunate to have an amazing team of over 500 volunteers who have graciously offered their skills and their background and their talents as mentors. So throughout the chat window today, if you have questions, keep an eye out for answers from mentors. But in reality, the chat window tends to fly by so quickly, you'll also want to turn to Ed, the course's Q&A platform, which you should have a link from the course's website, as well as from my emails yesterday as well. If you have any trouble following along today, or if you're feeling a little less comfortable, you get a little lost, you have technical difficulties, not to worry, everything will be posted online so you can work through everything later at your own pace, on demand, however you'd like, in addition to continuing to asking questions via Ed. Before we begin, we have this tradition of taking a group photo so that everyone has a little souvenir from today. If you're comfortable, go ahead and turn on your camera, and we need everyone to smile their best and wave for a few seconds because there's over 500 of us in the room now. So it's going to take CS50's team behind the scenes, Ian and Rungshin and Valerie, a few moments to page through all of the screens and take a whole bunch of photos. Hopefully we'll get you at a good moment because we're only going to get one screenshot per screen, but feel free to smile your best, vary things a little bit if you want to see how we might look waving with the other hand, but hopefully we'll catch you at a good moment.
Also, thank you.
All right, thanks to Ian behind the scenes. Without further ado, allow me to introduce CS50's own Brian Yu, who not only teaches CS50's introduction to web programming with Python and JavaScript, but also CS50's introduction to artificial intelligence, or AI. Brian, over to you.
Thank you so much, David. And welcome, everyone. It's so good to see everyone here today. Welcome to another of CS50 seminars. And today, as David mentioned, we're going to be introducing SQL, which is a language, as we'll soon see, that's very helpful for use with databases. So while I'm demonstrating SQL today and showing you how to use it, definitely feel free to ask questions. If you haven't found it already, there's a chat button at the bottom of your Zoom window where you'll be able to ask questions. I'll be keeping an eye on that throughout today's seminar to try to answer as many questions as I can. And for any questions that I'm not able to get to, we have a fabulous team of mentors who are in the chat as well, who are able to help you answer your questions too. A few logistical things to get out of the way before we get started. If you don't already have a GitHub account, go ahead and head to this URL, github.com/join, which I just pasted into the chat window. You'll need to sign up for a GitHub account to be able to sign in to some of the course's tools that we'll be using in just a moment. We also have a course discussion forum where you'll be able to ask questions. And in particular, there will be some times today where I'm going to stop talking and give you an opportunity to work through some data and database related problems. And during those times, if you have questions about any of the problems that you're working on, feel free to post a question to Ed, the course's discussion forum. I've pasted the link to Ed in the chat. It's cs50.ly/seminars/ed. And there you'll be able to ask questions about any of the problems that you're working on, and the mentors who are with us today will be able to help answer your questions too. And finally, though we won't use it for a little bit, ultimately what you'll want to do is go ahead and sign into this URL, ide.cs50.io. This is CS50 IDE, a cloud-based development environment for writing and running code. And we'll be using CS50 IDE today to access our databases that we're going to be working with and to run some queries on those databases. But more on that relatively soon. At any point today, if you have any technical trouble at all, definitely feel free to just ask a question in the chat or on Ed, and the mentors will be able to help you resolve. But with that in mind, let's go ahead and dive right in today. So today is all about storing data and asking questions about data. So before we even get to SQL, which is a language that we're going to be able to use to manipulate data and databases, let's start with one way you may have worked with data before, even if you've never used SQL before, and that's a spreadsheet. So I'm going to share with you a spreadsheet. And this spreadsheet includes spreadsheets taken from IMDb, the website, and it's data about television shows. It's not every television show in their database, but it's 500 of their more popular television shows that are all located just in this spreadsheet here. And you can take a look at this spreadsheet, and I have a few questions for you. My first question, and feel free to post your answer in the chat if you'd like to offer an answer to these questions, is how is this spreadsheet organized? What do the columns of this spreadsheet represent, like columns A, B, C, D, and E? And what do the rows represent? So what do the columns mean? What do the rows mean in this spreadsheet as you're trying to read and understand this data? Yeah, I'm seeing a lot of good answers. I see a lot of people saying every row represents like one record of data, one piece of data, which in this case corresponds to like one television series. So we have a bunch of different television series, each of which is just one row in this spreadsheet, and every row corresponds to a different television series. And then I see different names being given to the columns. People are calling them fields. People are calling them attributes. Yeah, all of those are very good ways of describing it. Each of these columns is representing something about that television series, some field or property or attribute of that television series. I like the different words people are giving to it. So we have the title of the series. We have, for example, what year that series was first aired. We have how many episodes there are so far in the series. And then IMDb allows users to rate each series on a 0 to 10 scale. And so each of these television series also has a rating, as well as the number of votes, how many people have actually voted for that television series. We see that some of these TV series, but not all, have a genres column where we've listed the genres that are associated with that television series in IMDb's database. So one might be action and adventure and drama. This one's action and comedy and drama, for example. And then finally, in column G, it's a relatively wide column, we have the stars of the television series. So who are all of the people that starred in that series? We can see for every television series, we just have a list of people where each person is separated by a comma of the people that starred in that television series. So I'll pose the question to you now. What problems do you see in this database design? What could be better about the way that we've organized data inside of this spreadsheet? I'll let you respond in the chat. Yeah, Konstantin says it's difficult to find data, and I'd like people to elaborate on that. What's difficult to find? Baoyun says some of the cells are empty, and yeah, that's certainly true, and that's just because IMDb's database might not have fields for everything, and so we do have a number of these cells that are empty. And yeah, people are saying it's a little bit hard to find particular people or maybe particular genres. And if you imagine trying to find all of the like dramas, for example, you'd really want to look in this column for anything drama, but a cell might not be exactly drama. It might be crime, comma, drama, comma, mystery. This one is action, comma, adventure, comma, drama. All the people are not very well organized. You notice these lines are so long that some of them are getting even cut off in the visual view here. And so I've got all of the data in one place, so to speak. But the data is not particularly well organized. There are probably ways I can organize this data so that it's maybe a little bit cleaner, maybe more efficient and more effective for a computer then to be able to search through this data and to be able to figure out what's going on. So let me pose another question to you. What could we do to improve upon this organization of data inside of this spreadsheet? What could we do? Yeah, I see a few people suggesting that we should try to separate all of these elements that are just separated by commas. These commas, they're a nice human convention for being able to quickly read something, but it makes searching for things a little bit trickier. If I'm looking for drama, I have to be very careful. Drama might be the only thing in genre, or it might be in between two different commas, and I want to be careful not to select someone's name that might just have similar characters in the same order as part of someone's name too, if I'm just trying to do like a Command or Control F to be able to search through it. And so let's try and improve upon this a little bit. We're going to make the structure of our database a little more sophisticated, but as I'm going to argue, it's going to be in a way that'll be a little bit better organized, easier for us to be able to look through and search through a little later. So here is version 2 now of how I've organized this information about shows. And immediately looking at this data here, what do you notice that's different? What's different about version 2 of this sheet compared to version 1 that we were dealing with before? Yeah, a lot of people are saying I've got a new column here. I've got an ID column, which I didn't have before. And this ID column just contains a unique number for every television show. And that's useful because it might be the case, and it is the case, in fact, that there are times in IMDb's database where multiple television shows might have the same title, or multiple television shows might have the same year. And it's important when different TV shows might have the same title that we be able to distinguish between them, that we have some way of uniquely identifying every record of our data. And so one conventional way of doing this in the world of databases is to give every row a unique ID, just some number that will uniquely identify it. That way, even if two shows have the same title, they'll have two different IDs, and so we're not going to get confused about them. You might imagine the same thing would apply to if I had a database of people, for example, where I might have lots and lots of people, some of whom are going to have the same name, but if we give everyone a unique ID, then we can make sure that we're never going to get two people confused, for example. So everyone has an ID. It doesn't so matter what exactly these numbers are. These are just the numbers IMDb happens to use for the IDs for these shows, as long as each one is unique. No ID is going to be created twice. Joseph has pointed out that along the bottom here, I now have 3 different of these, what Google would call sheets, different sheets of my spreadsheet. We're going to start calling these tables, just different pieces of information. And what I've done is I've taken all of the data that used to just be in one sheet, in one table, and separated it a little bit. You'll notice I don't have all these cluttered, comma-separated lists in all these long columns that were stretching longer than I had room to fit in this window. I've now taken and gotten rid of all the information about genres, and I've gotten rid of all the information about people, and I've moved those to separate tabs. And so, for example, let's take a look at what the genres sheet looks like. Here's what that looks like. And here I have another spreadsheet, another table, so to speak. And this one just has 2 columns. It has one column called show ID and one column called genre. And the idea here is that this table is going to associate the ID of a TV show. And how do we know the ID of a TV show? Well, we added that ID column to the shows table, so that's how we know. And then on the right-hand side, we have listed is what the genre is. And notice that now, instead of a comma-separated list of genres, every element in this column is just a single genre, which is going to make it more efficient later if we ever want to search for all the dramas or all the fantasy shows or all the horror shows, because we know we can just look for exactly that cell without having to worry about checking to see if it appears in a comma-separated list or not, for example. And so what do I do if a television show has multiple genres? Well, we see an example of that here, that this show number 4574334, actually is associated with 3 genres, drama and fantasy and horror. And I represent that by having 3 separate rows, 1 row for each genre associating the show ID to the genre. So in this table, the show ID might appear multiple times, that I might have a show ID appear multiple times if that show is associated with multiple genres. And likewise, I can do the exact same thing with people. That here, if I want to keep track of like what are the people that starred in all of these shows, for example, well then I now have 2 columns again, one called show ID and one called name for just the name of the person, for example. And now I'm associating every show ID with a person that starred in it. And if a show has multiple people, then I might have multiple rows in this table that have the same show ID. And if a person starred in multiple different shows, that person might appear there multiple times with a different show ID. So we've made arguably some improvements. It might look a little bit more complicated, but now my data is separated a little bit. We call this process database normalization, where we're separating things into tables that are now related to each other. But does anyone want to critique this design of this database even further, actually? Anything else that might not be ideal about the way that I've organized this data, particularly in this people table? Let's take a look at the people table, and what could I do? Yeah, David is talking about how there are duplicate names. People are talking about these repeated values, that if a person was in multiple shows, I'm now storing that person's name multiple times. So it feels like I've done a little bit more work. I'm storing a little bit more space than I probably need to. Any other problems? Oh, yeah, someone else is suggesting that, and a couple of people are saying that these people might want to have IDs as well. I mentioned a moment ago that it might be the case that two people have the same name. And right now in this database, I don't really have a way of distinguishing whether, if I see the same name twice, is that the same person who is in 2 or 3 different TV shows? Or is it multiple people with the same name that just so happen to be in the database together? So that's potentially a problem too. And you might imagine that as I want to store more information about these people, because maybe in my database, I eventually want to store more data. Maybe I want to store what year every person was born in. So I might later on in life add another column to this database. I'm adding a column called birth that's just going to store in what year was each of these people born. And now you can start to see that I'm really starting to have some redundant information that I'm now storing for any particular person, what year they were born in. Every single time I'm keeping track of when it is they start in a show. So I'm storing their name multiple times and I'm storing their year of birth multiple times. And so it does feel like there's some redundancy here. It feels like there's yet another area where I can improve upon the design of this spreadsheet. Anyone want to offer an idea for how I might improve upon this? Yeah, people are suggesting maybe I need a new sheet. And so how are these sheets going to be related to each other? I agree, maybe I want one more sheet. Rogov is suggesting that every person should get an ID. And so just as we had every show get some ID that you uniquely identify every TV show, let's give every person a unique ID to uniquely identify people. That's going to prevent us from that's going to help us from getting confused about whether multiple people might have been in the same TV show. And now how do I represent who starred in what TV show? What am I going to do then? Yeah, so people are suggesting I need some table that is going to link these things together. Some table that's going to link a television show with the person that starred in it. So let me now show you version 3, our final version of this spreadsheet. And this one, I'll go ahead and send you the link to this one as well, because we're going to be working with this spreadsheet in just a moment. But inside the chat, you can find the link to this spreadsheet. And if you go to the website for the seminar, it's the same place that you found the URL for today on cs50.harvard.edu/x. You should be able to find a link to this spreadsheet too. And here now I have 4 different sheets. I first have this shows sheet, which is the same as the one we've seen before. I have this genres sheet, which is the same as what we've seen before, associating the ID of a show with a particular genre. But what's new now is that I have this people sheet. And this people sheet now associates every person and their birth year with a unique ID. Now, just as every television show had a unique ID, now every person is going to have a unique ID too. And we're then going to be able to use that information to link people to the shows that they starred in. And that information is stored inside of this stars table here. Now, this table looks a bit cryptic. There's no words at all. It's just 2 columns of numbers. But one of these columns is called the show ID, and one of these columns is called the person ID. And the way to read or interpret this table now is that every row of this table is going to associate one television show with one person who starred in that television show. And so this is saying that person number 908116 starred in television show 384766. And we're representing that for every person that starred in every show. And so this is maybe different than the way you've necessarily used spreadsheets before. It's a little bit unusual. So what I thought we'd do now, before we dive into SQL itself and learn how to write queries inside of the SQL language, let's just work with this spreadsheet and get an understanding for how we've organized this database now inside of what we're now calling a normalized database inside of this spreadsheet. And so what I'm going to do is have you all go to this spreadsheet again. I'll paste a link to that spreadsheet in the chat. And again, you can find it linked from the website for today's seminars. But I'd like you to take maybe 10 minutes or so on your own and try to answer these questions based on the spreadsheet. Question number 1, in what year did Black Mirror first air? Question number 2, what genres are associated with the show Stranger Things? Question number 3, who are the stars of The Office? And question number 4, which shows has Jennifer Aniston starred in? And so what you're going to try to do, oh, and sorry, I think I gave you the wrong link for the spreadsheet. Let me give you the corrected link. Here is the link to that spreadsheet. Go ahead and take 10 minutes on your own, open that spreadsheet up, and try to answer those questions. So I'm going to stop talking, give you 10 minutes to try to answer questions. If you run into any trouble, post in the chat, and you can ask the mentors for help. You can also post on Ed, the course's discussion forum as well. So I'll give you 10 minutes to work on that, and we will follow up then with thinking about how you might have answered those questions. I see that some people are having trouble accessing the spreadsheet. If you're having trouble accessing the spreadsheet, go ahead and try this URL that I just pasted into the chat. That URL should get you access to the same spreadsheet, and hopefully that one should be able to handle the traffic. So if you're having trouble accessing the spreadsheet, head to the URL that I just pasted into the chat. I'll paste it again so you can see it. And that should give you access to the sheet. Again, we'll reconvene in about 9 minutes or so. I'll put the questions up on my video tile, and you will be able to take a look at it there. All right, welcome back, everyone. Hopefully you had an interesting time trying to figure out answers to those questions. But let's give this a try. Feel free to paste your answers in the chat as I ask them. But in what year did Black Mirror first air? If you'd like to offer an answer, just post it in the chat. All right, let's see what people are saying. I've pulled up the spreadsheet as well so that I can show you. Yeah, everyone's giving me the correct answer. 2011. You would find that by just going to the shows table. I'm just going to search for Black Mirror. And all right, we see that the year that is associated with Black Mirror is in 2011. So that one's relatively straightforward, hopefully. It's all just located in one table. Next question was a little trickier. What are the genres associated with Stranger Things? All right, people are giving me drama, fantasy, and horror. Very good. How would you have known that? Well, I would have started in the shows table and looking up Stranger Things, as I just did with Black Mirror. Here's Stranger Things. I don't see any genres listed in this row, but I do see a show ID, 4574334. And so let me just take that show ID, 4574334, and head over to the genres table, where now I'm going to try to find that show ID. So let me just search for it. All right, here it happens to be 4574334. It appears in the table 3 times. So we know that it is indeed drama, fantasy, and horror as the 3 genres associated with that show. What about the next question? Who are the stars of The Office? Stars of The Office. All right, I'm seeing a good list. It's a relatively long list, but how would we find that out? I would go to The Office, and I'd say, okay, what is The Office's ID? It's 386676. I'll go ahead and copy that. And now head over to the stars table. I want to know who starred in The Office. And let me now just search for that number, 386676. Here it happens to be. And it appears 1, 2, 3, 4, 5, 6, 7 times, it would seem, which tells me there are 7 people that starred in The Office. And here are their person IDs. And I could look up each of those person IDs one at a time. And for each person ID, I could copy it, head back over to people, and see, all right, who is the person that starred in that? And now, and I could do that with all the rest of the people. But now for the last question, Jennifer Aniston. In what shows did Jennifer Aniston star? I'm seeing Friends and The Morning Show. This was probably one of the trickier ones to answer. You got the answer right. But if we look up Jennifer Aniston, we see that she has ID number 98. And so I would want to go to the stars table and look up the number 98. The problem is the number 98 appears as like part of the cell for many other numbers. This person ID, for example, is 933988. There's a hidden 98 in the middle of it, makes it a little bit tricky. So you would either have to search it all manually to try to find it. Google Sheets gives you some ability to try to search more intelligently, where I can say match the entire cell contents before I search to only find exactly the number 98 and not anything else that would appear there. But even that you might not have had access to if you were on the web version of the spreadsheet. And so I would have to manually try and find all the 98s, go back to the shows and look it up, and then be able to find, okay, here's the morning show, for example. So that would have been one way. Piratheep suggesting that I could have sorted by the person ID. That's certainly true. I could have gone to the stars table, sorted it by this column B here, and then looked for all the 98s. Although that would have required me to now additionally sort all of the data. And that, of course, is going to take some time as well. And so we're going to try to improve upon this. We're going to try to make this a little bit better. And the way that we're going to do this is not by using a spreadsheet anymore, but instead to use a database. And in particular, we're going to use SQL. SQL is a language that's designed for relational databases. And all the relational databases, for now, you can think of as a way of organizing data into tables that have relationships between one another. Exactly what you're seeing here, where we have 4 tables, shows and people and stars and genres. And these tables are related to one another by way of these IDs. We're using the IDs to connect together one show with one genre. We're using it to connect together people and the stars that they showed in, for example. And so ultimately, we're going to learn this language called SQL such that we can write a SQL query to ask a question about the data in our database, and the database will give us the answer. We don't have to go manually hunting through all of these sheets to try and find what it is that we're looking for. And so here's how we're going to do that. To start, go ahead and head to ide.cs50.io. This is CS50 IDE, and it's where we're going to be spending our time today. And I'm going to additionally give you a database to download. So I'll go ahead and send it to you now. This one's a relatively large database, so it might take some time to download. But go ahead and try and download this first. I'm going to paste the link to it in the chat, and I'll also show you the link on the slide here. It's on cdn.cs50.net/2021/x/seminars/SQL/shows.db. And it's that file, shows.db, that I'd like you to download now. And once you've downloaded it, go ahead and upload it to your CS50 IDE, which you can do just by dragging it into this left-hand section of the IDE, which if you've never used the IDE before, is the file browser. This is where all of the files for your database are ultimately stored. So go ahead and take your shows.db file and drag it into the left-hand side of your CS50 IDE. That will upload the file to the IDE. So again, here is the link for the database to download, and I'll give you a moment to download that database file. It ends with .db. That's how we know it's a SQLite database, which is just one example of a database that uses the SQL language, and it's the one we're going to be using today. And again, once you've downloaded that database, go ahead and upload it to CS50 IDE. And you don't need to do anything else after that. We'll get started in just a moment with showing you how you can query this database to get access to the information you want. Devin, you're asking how to upload the file. You should just be able to drag your file from your computer into this portion of the IDE. Otherwise, you can go to File, Upload Local Files inside of CS50 IDE, and that should work too. After you've downloaded the database file, you can then upload it back to CS50 IDE after that. Bertrand's showing you another way that you could do this using the command wget. You can type wget into the IDE followed by the URL of the database file, and you're welcome to do that instead of downloading the database and then uploading the database. That would work just fine too. Yeah, thank you to Aman for pasting the entire command. If you just take that command, paste it into your CS50 IDE into this bottom portion here, which is called your terminal, that should be able to download the database directly to your IDE. All right, so once you've done that, and if it's still downloading, totally okay, you can follow along for now. And once it's done, you should be able to follow these solutions too. But what I'm going to do is I'm going to go into my terminal window here, which is in this bottom portion of CS50 IDE, and I'm going to run a command as follows. I'm going to run SQLite 3. SQLite 3 means I'm going to open up a SQLite database, and 3 is just the version of SQLite that I happen to be using. Space, and then the name of the database that I would like to open up. And the name of the database in this case is called shows.db. So I'm going to, again, in this blue section of my IDE, this terminal window, type SQLite 3, space, and then shows.db. And that is going to open up this shows.db database so that I can start finding out what data is inside. Once you've written this command, SQLite 3, space, shows.db, go ahead and just press return. And what you'll see here is the word SQLite followed by an angled bracket. And this is what we call the prompt. This is where I now can write a SQL query, instructions to this database. And when I do that, I'll be able to see the result. If it's taking a long time to download, go ahead and just use the wget command. Again, just go directly to CS50 IDE, go to your terminal window, and paste in this command that I just sent in the chat, wget, followed by the URL of the database, and that should be able to download it to your IDE as well. All right. So once I'm now inside of this database, what I'd like to do is understand how it is this database is structured. What is the structure of the database? What are the tables in the database? And what are the columns for these tables as well. And so the way I can do that, when I see this SQLite prompt, is I can type this. I can type a dot, just a period, immediately followed by schema. No spaces, just dot followed by the word schema. And that's going to show me the schema, in other words, the structure of this database. So again, I'm going to type dot schema and then press return. And what I'm now going to see a bit cryptically is all of the tables in the database and how it is that these tables were created. So you can see that a table called shows was already created. I can see that on this line that says create table shows. And so that's one of the tables. And I now see here are all of the columns in the shows table. You'll notice that every show has an ID column. Every show has a title. Every show has a year. And every show has a number of episodes. And those are the same columns that we were just working with a moment ago too. And so we have that shows table there. This last line here, primary key ID, don't worry about it too much, but in the world of databases, a primary key is just how it is that we uniquely identify a television show. So the ID is how we're going to uniquely identify the television show, whereas the title, that might not be unique. There might be multiple shows with the same title. The year also might not be unique. Multiple shows were released in the same year. The number of episodes is not unique. So the ID, that is how we are going to uniquely identify that show. Meanwhile, after the shows table, we have a table called genres. This genres table has two columns. One column called show ID, referencing a particular show, and we've seen that already in the spreadsheet version of the same thing. And we have one column called genre, which is just going to be some text describing the name of that genre, for example. And you'll notice that these columns also have types. If you're familiar with programming a little bit before, you might know that pieces of data generally have a type, so we know what kind of information is being stored. And so here we're seeing that show ID is an integer, meanwhile genre is some text, for example. And this last line here, again, don't worry about it too much, but this is saying foreign key show ID references shows ID. What does that mean? Well, a foreign key just means one of the columns in this table is referencing some primary key in another table. And so here we're saying that the show ID column of this genres table is referencing the ID column of the shows table. That if ever I see a value in the show ID column of this genres table, what it means is that I'm talking about the ID column of this shows table. That's how these two tables are related. Remember, again, SQL is a language for working with relational databases, databases with tables that here are going to be related to one another. And again, if you're having any trouble with these steps, post a question in the chat. Our mentors are helping students as they run into any trouble if they're having any problems with these steps. But then we have a stars table. The stars table, again, connects a show ID with a person ID. We also have a writers table. We didn't see that before, but in addition to keeping track of who is the star of every show, I might care about who wrote the show, or multiple people if multiple people were the writers of a particular show. And so this writers table has a very similar structure. The writers table stores a show ID for the ID of the show, and then a person ID for what is the ID of the person who wrote that show. And then finally, we have two last tables. We have one table just for ratings. Turns out IMDb has just separated ratings into an entirely separate table, just probably because that table is updated often, and so you want to keep it a little bit separate. And so ratings associates a particular show, a show's ID, with what rating it has, which is a real number, so a number that might have a decimal point, for example, somewhere between 0 and 10, and then how many people have voted for that show. And then finally, we have a table called people, that has columns for an ID, for the name of a person, and also for in what year that person was born. So a whole bunch of tables, each of which has different columns that are making reference to different pieces of information here. Someone was asking about what does not null mean? Not null just means the field can't be empty. That databases sometimes want to allow fields to be empty. For example, you might have noticed that we didn't have birth years listed for all of the people in the database a moment ago. Therefore, the birth year is not a not null field because the birth year might be null. It might be empty. In contrast, the name field for a person, that in the database should never be null. We always need at least to have the name of the person. And so here, next to name, we see not null as well. Spreadsheet is asking, so does the people table contain both stars and writers? Yes, that's true. The people table will contain all people associated with the show, both stars and writers. And it might be the case that some person might have starred in a TV show and also wrote either that TV show or another show. And so they just have one ID, they are one person, but they might appear in both the stars and the writers table. If you're Alexandra, if you're seeing PHP Lite Admin, odds are you double-clicked on the show.db file instead of what you should have done, which, if you're following along with me, go into the terminal window here. You'll type in the command SQLite 3 followed by shows.db. So SQLite 3 space the name of the command shows.db. That should give you, sorry, I typed the name wrong. SQLite 3 shows plural.db. That will give you the SQLite prompt. And then I typed .schema, which is just a SQLite command that shows me all of the tables. And again, it has to be .schema and not just schema for this to work. All right, so we've started to understand the structure of the database. Now for the interesting stuff. Now, how do I actually take this database and ask questions about it? How do I get information from the database? Well, here we're going to write a SQL query. And the first query I'm going to write is select star from shows, and then a semicolon. So what's going on here? Select star from shows. You can try typing this command in your own SQLite prompt and then just press return. What's going on? Well, select is a command in SQL that says I would like to get data from my SQL database. After I select, I need to specify a few pieces of information, though. I need to specify first, what columns do I want to select? A table might have many columns. Maybe I don't want all of the columns. But here, the star just means give me all of the columns. So if there are 5 columns, I'll get all 5. But select star means let me get all of the columns from the table. And then I need to tell SQL, what table do I want to get the data from? Remember, there were multiple tables. I had stars and people and shows and genres and writers. And so I need to say from shows to mean this is the table that I would like to select my data from. Select star, meaning select all of the columns from the shows table. One of the nice things about SQL is that it reads very much like English, so you can almost read aloud the query and understand what it is that query is doing. So again, select star from shows, followed by a semicolon to say this is the end of the statement. And once you've written that query, select star from shows, I can press return. And what I'll immediately see is it takes a little while to print all of them out because there's a lot of them. But now I'm seeing printed out all of the television shows that are inside of the database. And for each of the shows, I'm seeing an ID for the show. I'm seeing the title of the show. I'm seeing in what year that show was first released. And I'm also seeing a number representing how many episodes that show happens to have. So this is a lot of data. Notice it took several seconds for me to get all of this data printed out. And so this was probably not the way that I wanted to select data, because odds are when I want to get data from the database, I don't want to get all of the data. I don't want all of the television shows from this database. What I'd like is I'd just like to get a particular show. If I just want to get one piece of information, for example, I just want to specify, I don't want all the rows of data. I want to filter down on the data. Yeah, I like Michael's phrasing of this in the chat, to filter down on the data to just get access to the information that I want. And so how could I do that? Well, I'm going to now run another query. It's going to look very similar, but I'm going to add a clause to the query. I'm going to say select star from shows where title equals, and then in quotation marks, Black Mirror. Imagine, for example, that I wanted to find out in what year Black Mirror first aired, answering that question that we had from before. And so the way that I could answer that question is by running this command here. It starts the same way. Select star from shows, meaning let me get all of the columns from the shows table. But then I added what's known as a where clause. I'm saying don't get me all of the rows of data. Let me filter down on those rows of data with a particular criteria to specify which rows I actually care about getting. And here I'm saying black mirror in quotation marks to say I only want you to give me the rows where the title is equal to black mirror. And so I can type that query. I'll press return. And what I see now is that instead of seeing thousands upon thousands of television shows, I just see one television show. I see a television show with this ID, 208-5059, a title of Black Mirror. I can see the year that it was released was 2011, and I can see that there were 22 episodes. So this was the equivalent of what you were doing with the spreadsheet a little while back, where you were just searching for the word Black Mirror, or the words Black Mirror, and then finding what year happened to be associated with it. Here we're doing the same thing, but we're using SQL, this language, to specify what it is that I care about finding. I'll give people a moment to catch up. Again, to get here, if people are struggling, what I did is I first downloaded the database and brought it into my IDE. You can do that by uploading the file to the IDE or by using the wget command that was pasted by Pia just a moment ago into the chat. But then in the terminal window, what I typed was SQLite 3 space shows.db. Once you do that, you'll see this prompt, SQLite followed by an arrow. And now I can type my queries. I can type select star from shows where title equals Black Mirror. And that shows me this result here. I see Black Mirror, and I'm able to see what year it was released in. So now, for example, let's imagine that my results might not just have a single output. Right now, Black Mirror, there's only one show in the entirety of IMDb's database that is called Black Mirror. But let's try a different show. Let's try The Office, for example. And I can say select star from shows where title equals The Office. And what you'll notice now is that there are like 6 different television shows, all of which are in IMDb's database, all of which are called The Office. How am I able to distinguish between them? Well, each one has a different ID, and each one was released in a different year, and each one has a different number of episodes in this case. And so while the titles are the same, the other columns might not be the same. Now, maybe imagine that I want to find out like what year were all of the different versions of The Office released, and I could look that up just by looking at this column. But if I'm asking that question, then I don't really need to care about the ID column. I don't need to care about the episodes column. And so SQLite also allows you to specify not that you want all of the columns, but just that you want some of the columns. So I could say something like select title, comma, year from shows where title equals The Office. And now what you see is that the only columns I get back are the title and the year columns. So if I only care about getting information from those 2 columns, I can tell SQL, don't bother giving me all the other columns that I don't care about. Just give me the columns that I do care about. So up above, I use select star to say, get me all of the columns. Now I'm saying, just give me these 2 columns, title, comma, year, as the only 2 columns that I actually care about here. I'll pause to give people a chance to catch up or ask questions. People are asking about case sensitivity. The keywords in SQL are not case sensitive. Select could be lowercase, from could be lowercase, for example. I'm putting them in all uppercase just for making them visually distinct. It's also a convention that you'll often see because I'm putting my columns in my table and my table names in lowercase to make it clear. And then the keywords that are part of SQL itself, those I'm putting in uppercase. It's a good practice, as was mentioned in the chat, but it doesn't have to be done. You can use lowercase here too. All right, so what else can I do with trying to select data? Well, let's imagine that I want all of the shows that are going to be released this year or sometime in the future. So shows that not just are slated for 2021, but that might also be already scheduled for 2022 or some future year, for example. How could I do that? Well, I don't just have to say that something is equal to something else. I can use greater than or less than to be able to perform comparisons. So I could say, for example, select star from shows where year is greater than 2020. That's going to have the effect of getting me all of the shows that have a year column that is 2021 or 2022 or some future year. Dipayan is asking, what does the star mean? The star means I want to select all of the columns. That there might be multiple columns in the table, and I would like to get all of those columns. So let me try this. And now what you see is very quickly, I got a big list of television shows, but it's only the shows that are released this year or in the future. So 2021, and if I search through this, there are a couple of like 2022s that happen to be in this table as well. So it's all of the current ones and the future ones. What if I wanted to know how many shows are going to be released this year or in the future? Like how many shows were even output here? Well, I mean, it's not a terribly long list. I could go through all of these and just like count up exactly how many there are. Again, to recap, the query that I ran was this query here: select star from shows where year is greater than 2020. That is one command that I could have used in this case to get access to all of those shows that are going to be released this year or sometime in the future. But if I wanted to count them, it turns out that much as programming languages you might have used, like Python, have built-in functions that you can use to be able to quickly get access to information. SQL has other functions that you can use that are built in to SQL as well. And so here's the command I'm going to run. It's not going to be select star from shows where year is greater than 2020. I'm going to say select count star from shows where year is greater than 2020. So what's going on here? Well, I'm saying not select all of the columns, but select count of all of this data, meaning just give me a number. Give me how many rows would I get back if I were to run this query for all of the shows whose year is greater than 2020. And if I run this, I see the answer, as Joseph has pointed out in the chat, is the number 615. So there were 615 shows that matched that query, that had a year greater than 2020. Why did it print count star here? That's just the name of like the column. It's a label for this column that's telling me, all right, here's the count. And it's telling me that the count is 615. Count just happens to be a function that's built into SQLite itself, which means we can use that function inside of our database anytime we care about trying to get access to information. Let's do one other example before we go back to the original questions that we were trying to answer. Someone was asking a question, what if I don't want to search for an exact title, but I only want to search for, let's say, part of a title, for example. Like I want to search for every show that mentions the Titanic, that any show about the Titanic, if the word Titanic is in the show title, I would like to query for it. How could I do that? Well, here I can run a query like this. Instead of select star from shows where title is equal to Titanic, which would be just give me the shows where the title is exactly the word Titanic, instead of the title being equal to something, I'm going to say where the title is like, and then I'm going to use these dollar signs, or the percent signs rather, around the word Titanic. And these percent signs, they're just part of SQL syntax, so no worries if it looks a little bit cryptic. But the point of these percent signs is the percent signs mean something can go here. There might be some text at the beginning of the word. There might be some text at the end of the word. But as long as Titanic is somewhere inside of that title, then we're going to search for it. So select star from shows where title is like Titanic. And if I do that, well, and I press return, I get a whole bunch of shows that just happen to have the word Titanic in it. Titanic might be at the end of the title. It might be at the beginning of the title. It might also appear somewhere in the middle. And so that can be a helpful tool too. You might not use that all the time, but oftentimes if you want to be able to match on a particular pattern, you'll be able to do that as well, to be able to try to find the data that you're looking for. All right, so with that in mind, let's try to answer some of the questions that we were taking a look at before. So one of the questions, for example, was, how do I find the genres for Black Mirror? Can someone tell me, like, if I was to try and figure out what genres there are for Black Mirror, how might I start that? Give me a query that I might use if I was going to start trying to answer this question. I want to find out what genres are associated with Black Mirror. What's the first thing I need access to? Yeah, Marion is saying that eventually I'm going to need to select from the genres table looking for Black Mirror's ID. But what do I need to do before that? That's a good place that I'm eventually going to go. I like Arav's suggestion, which is I need to figure out what is Black Mirror's ID. Yeah, multiple people are suggesting that now. I need to know first and foremost what is Black Mirror's ID. And once I have Black Mirror's ID, then I can go ahead and try to figure out what the genres are. So let me here say select star from shows where title equals Black Mirror, or actually rather, I think we were looking for Stranger Things genres. Let's do Stranger Things. So select star from shows where title is equal to Stranger Things. That was the question we were asking. I press return. And one interesting thing that's of note here is that there are two shows that both happen to be called Stranger Things. And I just happen to know that the version of Stranger Things that I was talking about was the version that first aired in 2016. That's the one that I wanted. And so if I wanted just that result, what I could do is I could add to this query. I could say where title equals Stranger Things and the year equals 2016. So that's what I've done. Notice that up here on this very first line, I'm selecting star from shows, getting all of the shows where the title is Stranger Things. And it turned out there were two shows that matched that description. Two shows called Stranger Things, but I only wanted one of them. I wanted the one released in 2016. So I revised my query a little bit. Select star from shows where title equals Stranger Things and the year equals 2016. So I can combine multiple filters, so to speak, in this way. And when I do that, I find this ID here as the ID of Stranger Things. And now that I have the ID, now I can say select star from genres where the show ID is equal to that ID. And I'm just pasting that exact same ID. So now remember, the genres table has one column called show ID. That's just the ID of any particular show. And the other column in the table, the genre column, tells me what the genre is. So I'll go ahead and press return here. And now what I see are the three rows in the genres table that match that show ID. I see one that says drama, one that says fantasy, one that says horror. And if I didn't care about getting the show ID column as well, I could instead just say select genre from genres where show ID equals that show ID. I could just specify the one particular column that I want, select genre from genres where the show ID is that number. And now all I get as my result are the three answers: drama, fantasy, and horror. That is the answer to my question. Someone's asking, why don't I need quotation marks around this number, 4574334? It turns out it's because of the difference in types between these values. For something that's text, like Stranger Things, text goes in quotation marks. Something that's just an integer number, like the show ID, that does not need to have quotation marks. Desiree is asking, could I combine these things? I had to do two separate queries to get my information. I first selected from shows where the title is Stranger Things and the year is 2016, and I found out Stranger Things ID. And then I used that ID inside of this query to say, get me the genre for that show. Two separate queries to get access to the information. Is there a way to combine them into one? It turns out there is, and that's what we'll take a look at right now, trying to take these two queries and combine them into one query. And this is where things are going to get a little bit trickier, but we'll give it a try. So remember, this is the command I ultimately want to run. Select genre from genres where the show ID is equal to, and then the show ID for Stranger Things. But imagine for a moment I didn't know Stranger Things show ID. I've got the same query. I've got select genre from genres where show ID is equal to, and then I don't really know what comes next. Well, what comes next is I need to know the ID of Stranger Things. And how would I get that? Well, I could run another select query. I can nest a select query inside of another select query to effectively run two queries, one after another. And so here, watch what I'm going to do. I'm going to press return to go onto a new line, but you don't have to do this. This could all be on one line, but I'm just doing this on a new line for clarity. Michael is right. I'm going to need an extra set of parentheses now to enclose this innermost query that I'm now going to run. And what I now want to do is I want to find out what is the ID of Stranger Things. And so I'm going to write select just the ID. That's all I care about, the ID, from shows where the title is Stranger Things and the year equals 2016. I'm going to end those parentheses and then the semicolon. So this is the most complex query we've run so far. So I'll try to walk through it slowly, and definitely if anything is confusing, ask a question in the chat, and the staff and our mentors today will try to help you out. But what I've done here is I'm saying select genre from the genres table. That's the same as before, where the show ID is equal to, and before I literally just pasted in the ID of the show itself. But I don't know the ID of Stranger Things, so I need to select it. So I'm inside of parentheses running another select query, nesting a select query, where I'm saying, give me the ID from the shows table, where the title is Stranger Things, and where the year is 2016. I press return, and I get the exact same answer. I get drama and fantasy and horror. Those are the three genres associated with the show. And I did that by just nesting the query into one big query rather than have to do this in two separate steps of look up the ID first and then use that ID in the query again. Someone's asking, how did I get onto the second line? After the equal sign, I just pressed return on my keyboard. That will move you onto a new line. And SQLite knows that I'm not done because I haven't typed a semicolon yet. When I type the semicolon, that's how we know that's the end of the query. And so from there, we're able to see the result. You didn't have to do this on multiple lines. You could have done this just on one line, but I've done this on multiple lines just to make it a little bit clearer. I'll leave this here to give people an opportunity to catch up, to try this query for themselves. And then we'll talk about how we might have answered the other question about the office. Minwoo is wondering if we could nest even more, and indeed we can. And in fact, we'll do that in just a moment. So let's try now to answer one of the other questions from earlier. We were trying to figure out who are the stars of The Office. So how could I find that out? Well, let's first try and figure out what is the ID of The Office. Let's select star from shows where the title equals The Office. And you might remember from before that I've got a bit of a problem here. The problem is I've got 6 shows that are all called The Office. And I don't really know which The Office I'm referring to. I might not remember exactly what year The Office was released, but I'm pretty sure The Office that I care about is the one with the most episodes. So one thing I might like to do is right now, these records aren't in any particular order. I might like to order them by their episodes. How many episodes do they have? So it turns out there's another clause I can add to my query to sort the results in a particular order. Let me try this. Select star from shows where title equals The Office, and then order by episodes. So the first part of the query is exactly the same as stuff we've seen before. Just give me all of the shows where the title is The Office. What's new, the new thing I'm introducing you to now, is this right here. Order by episodes says I would like these results to be in a particular order, ordered by a column. What column do I want them ordered by? Well, I want them ordered by the episodes column. So I'll run that. And now I see that these results are ordered by number of episodes. I see the one with only 6 episodes first, then 8, then 14, and so forth. Michael and Bertrand are both asking, could we do this in reverse? Right now, I've got lowest number of episodes to highest number of episodes. But if I really just care about like the one episode with the one show with the most number of episodes, what I probably care about is not putting them in lowest to highest order, but in descending order, from most number of episodes to fewest number of episodes. And there's a way to do that too. The way that I would do that is I'd start the same way, select star from shows, where title equals The Office. Then I'm going to order by episodes, and then I'm going to add DESC to the end of the query. DESC, short for descending order, meaning largest to smallest. And now if I press return, I see all of the results now in descending order, from most number of episodes to fewest. And I can even add one other flourish to this query just to only really get the information that I care about getting. If I know that I only want the one show with the highest number of episodes, there's no point in me asking for all of the shows, all of them. Right now there's only 6, which isn't bad, but there might be more. What I really would like to do is just limit myself to just one result. I just want the one top result, and I don't care about any of the other results. So how could I do that? Well, I'm going to add a little bit to this query as well. I'm going to say select star from shows, where title equals The Office, order by episodes descending. And that part of the query is exactly what I've written already before. Nothing new there. What is going to be new is at the end of the query, I'm going to add limit 1. Limit 1 is an additional command I can add that is going to limit my results to just one result. I only want one result, the top one result. I don't want all of the rest if there are going to be more. I would just like the one. So I'll press return, and now I do see the ID for The Office. All right. I'll give people a moment to catch up and to ask questions if they'd like to. We're introducing a lot of new syntax here, but that's okay. Definitely feel free to ask questions if anything is unclear. Will limit 1 only give you the first one? Yes, limit 1 is just giving me the first result. And because I'm ordering them in descending order by number of episodes, that means the only TV show that I'm going to get is the TV show that happens to have the most episodes. Yeah, and as Bertrand noted, you could change the limit. Limit 2 would give you the top 2, limit 3 would give you the top 3, and so forth. All right, so now I'd like to find out who actually starred in The Office. Well, here's The Office's ID, this ID here. And so what I'll now say is select star from the stars table where the show ID is that ID. Remember that the stars table associates 2 pieces of information. It's associating the ID of a show with the ID of a person who starred in that show. So select star from shows where stars where show ID equals this number. I'll press return. And here's what I get. I get a whole bunch of person IDs. And those IDs are the IDs of all of the people that starred in The Office. I'll give people a moment to run that query too. And if I wanted to just select their IDs, again, I don't care about this column, I only care about the person ID column, I would modify the query slightly. I would say select person ID. I only want the person ID column from the stars table where the show ID equals this number. And I'll press return. And now here are just all of those person IDs. These are all of the person IDs for the people who starred in The Office. And so now, let me try to nest these queries the way that I did it before. I want to select their names now, right? Oh, getting just their person IDs, that's not all that useful to me. What would be useful to me is finding out what the names are for these people. And so how could I do that? What type of query would I run to try to get the names of all of these people? Well, all of the people's names, those are located in the people table. Remember, if you think back to our spreadsheet that we had here, the people table was the table that associated an ID of a person with that person's name. And so I want to look up all of those person IDs inside of this table called people. So let's now select the name column from the people column where their ID is equal to, let's try this for now, this query. Remember, this query that I've highlighted here is the query that's going to get me all the person IDs. So let's try that. So where the ID is that, I'm nesting a query within each other. But strangely enough, I appear to have run into a bit of a bug. I'm only getting one result. And this is a bit of a quirk with SQL itself. I've done something wrong. Anyone have a guess for what I might have done wrong here? There's definitely more than one person, right? There should be 7 people based on the number of person IDs that are here. What's the problem here? Yeah, the problem is this equal sign that a couple people have pointed out in the chat. The equal sign is checking if the ID is equal to one particular value. And if there are multiple values that I'm getting back from this query, the equal sign is only going to look at the first one. It's only going to look at this very first person ID, and it's not going to look at all of the others. So instead, there's a slight modification I'm going to make to this query. Instead of saying where the ID is equal to this select query, I'm going to say where the ID is in the result of this query. In will let you check to see if the ID is one of a sequence of possible values. So what's going on here? Inside this nested query, we're going to select a person ID from the stars table where the show ID is equal to the show ID for the office. So I'm getting all of the IDs of the people that starred in the office. And then I'm putting that query inside of another query. I'm saying, get me the names of all of the people whose ID is in the result of this query. And when I do that, now I get all of the people. I'm checking for anyone who has an ID that's in this list of IDs right here. And that then gives me all of the names of the people. All right, we've just seen a lot of new SQL syntax. If this is feeling like a lot or a little bit overwhelming, not to worry at all. It's a brand new language. It's a brand new syntax. In a moment, what we're going to do is give you an opportunity to try this out. This is actually all of the SQL syntax that I'm going to be showing you today. The rest of today's seminar is just going to be getting some practice with this syntax, getting used to it, and starting to feel a little bit more comfortable using this syntax we've seen here. But what you've seen here is everything in terms of syntax that you're going to be seeing. So if you're feeling like it's a lot, not to worry, we'll get plenty of opportunity to try to practice. Don, yes, you do need the semicolon at the end to tell SQLite that your command is over and you're ready to run that query. Otherwise, it thinks you might have more to say at the end of the query, for example. Joseph's asking, can you nest more than 2 times? Yes, you can. I could nest 3 times if I wanted to. For example, I could nest one more time just to get rid of this show ID here and just query for the ID, for example. And you'll have an opportunity to try that if you would like to. All right, so we've seen a lot of new syntax. What I thought we'd do is get a little more chance to practice with this. So I'm going to stop talking for about 15 minutes and give you an opportunity to work through some questions. And so here are the questions I'll have you work through. You're going to take this database. Again, you can access it via this URL. If you're in the IDE, you can type wget followed by this URL to download the database onto your own computer into the IDE. And use SQL by writing a SQL query to try to answer each of these 5 questions. In what year was Jerry Seinfeld born? Write a query that'll answer that question. How many shows have a perfect 10.0 rating in IMDb's database? What genres are associated with the show The Crown? Who wrote Arrested Development? And then what shows has Allison Janney start? So I'm going to give you 15 minutes to try using SQL on this database to write queries to answer these 5 questions. And I care about knowing not just what the answer is, but also what query you used, what select query you used in order to answer those questions. And this will be an opportunity to get some practice. If you get stuck with the syntax, which is totally okay, this is new syntax, it's challenging at first, I definitely understand that. Ask the mentors for help. Again, we have this discussion forum called Ed, where if you want to ask a question, you can click on the new thread button, click on question, and then just go ahead and click on SQL, which is the category for today. You can ask a question about your syntax, about how to do something in SQL. And again, we have a fabulous team of mentors who are here to answer your questions. If there's anything at all that's confusing, there was definitely a lot of syntax that we just introduced, but this is your opportunity to get some practice with it. So I am going to stop talking and give you 15 minutes to try and write some SQL queries to answer these 5 questions. So I'm going to start a 15-minute timer. You should see that timer up here on my screen, and I will talk to you in 15 minutes. All right, welcome back, everyone. Hopefully, it's totally okay, by the way, if you didn't manage to get through all of those questions, but hopefully you made a little bit of progress. But now we'll get a chance to talk about them. I'm not going to introduce any new SQL syntax, just going to understand how we can use all of the syntax we've just learned to try to answer these questions here. So the first question we wanted to answer was to figure out what year Jerry Seinfeld was born in. And does anyone want to give me a query by pasting it into the chat that they used to get the answer, and also what their answer was once you were able to answer the question? All right, so people are saying 1954, and it looks like you found that out by querying from the people table, which has information not only about the names of people, but also the year in which they were born. So I'm going to go into my database. Again, if you exited it for some reason, you can get back to it with SQLite 3 shows.db. Once I'm in that database now, I am going to run select birth, that's the only column I care about, from people, that's the name of the table, where the name is Jerry Seinfeld, and we see that he was born in 1954. Very good. So one table, we're selecting the birth column from the people table, and then we have a filter. We don't want all the people, we just only want the person whose name is Jerry Seinfeld, and that gives us our answer. Very good. All right, so now we wanted to know how many shows have a perfect 10.0 rating. Yeah, so the first thing to realize here is that the rating isn't actually in the shows table, and I can demonstrate that for you. Let me select star from shows. Instead of getting all the shows, I'll just say limit 5. Let me just show you 5 shows to demonstrate this. Here are 5 shows with their IDs and titles and year and episodes. Rating is not one of these columns, so it's a little bit different from the spreadsheet that we were looking at before. Instead, there's a ratings table. And if I want to see what the ratings table looks like, I can do select star from ratings and also do a limit 5, just so I can see what it looks like, what the data's like. And all right, I see show ID, rating, and votes. So what I really care about here is knowing how many rows in this ratings table have a 10.0 value for this rating column here. And so many people are suggesting to me a great query. I can just select star from ratings where the rating equals 10.0. And here now are all of the show IDs for shows that happen to have a 10.0 rating. Now, I could count them one at a time, but many of you in the chat are identifying that you don't need to count them. There's a function built into SQL that'll do this for us. I can instead say select count star from ratings, where rating equals 10.0. And instead of giving me all of the results, count is a function that just counts the results for me. So it's telling me there are 27 results, and therefore we see an output of 27 here, 27 shows that have a perfect 10.0 rating on IMDb. Ratings is a table, Davika, yes. And the way you would know that, by the way, again, you can type .schema into SQLite, and .schema followed by return will show you all of the tables in your database. So we're seeing there's a shows table here, but there's also a ratings table, and every ratings table has a show ID column, a rating column, and a column for the number of votes. And again, this foreign key, don't worry about it too much, but it just means that this show ID column is referencing the ID column in the shows table. All right, so next we wanted to know, what are the genres for The Crown? What genres? Yeah, I see a lot of really good answers. Really well done. There are a few ways you could have solved this. One would be, and perhaps if you're feeling a little less comfortable, this way is totally fine, is just to do it in 2 separate queries, to ask 2 questions, one after another. The first question is, what is the ID for The Crown? So I could say select ID from shows where the title equals The Crown. The shows table is the table I want. ID is the column in that table that I care about, and I only want the show whose title is The Crown. I press return. There's the ID for The Crown. And now if I want to know the genres, I can say select genre from the genres table where the show ID equals that ID. And that tells me The Crown has 2 genres associated with it. They are drama and history. Now, I see many of you have chosen to go the route of nesting queries, one inside of the other. That way is totally good too. I could say select genre from genres, where show ID is equal to, and then in parentheses, just include this query that I put on line 1. And then I get the exact same answer. So one way was get the ID of the crown first, then get the genres for that ID. This way here just combines the previous two queries. You can look at it right here and see how really we're just taking those two queries and composing them together, getting the ID for the crown, and then saying, get me the genres from the genres table, where that's the show ID. So either of those ways, perfectly appropriate. Both would get you to the same answer. All right, next question. Who wrote Arrested Development? All right, again, I'm seeing multiple ways of doing it. You could have done this in just a couple of separate steps. I want to know who wrote Arrested Development. That information's in the people table because the people has all the names of the people. But the writers, that's going to be the writers table. And the writers table links together two tables. It links together the people table and the shows table. So I know that I'm going to need to query somehow from those three tables, the people table, the writers table, and the shows table. So I could try this. Let me select the ID from the shows table where the title equals Arrested Development. That gives me one ID. That is the ID of Arrested Development. Now I want to know who wrote the show. So let me take the ID. Now let me select all of the person IDs from the writers table. Remember, the writers table is a table that links together shows and their writers, where the show ID is that number that we just got. And that's going to give us one person ID. And that's the person ID we care about. And so now I can look this up, select the name, I guess, from the people table, where the ID is that new ID, and that gives us the writer for Arrested Development. So 3 steps for 3 different tables. First, get the ID of Arrested Development. What is its ID? Once we know its ID, I can figure out which people wrote Arrested Development, because that information is in the writers table. And once I have that information, I can select the name of that person. I see a question, could we use join instead of nesting the queries? You certainly could have used join. I have not shown join in today's seminar because we're keeping things a little simpler for today, just introducing some of SQL syntax, giving you a taste of it, so to speak. But there's certainly more sophisticated syntax that you could look into if you're interested. Could you have nested this query? Yes, you could have. It would have been 3 layers of nesting. And what that would have looked like was this. Select name from people, where ID equals. And now I want the ID of the person who wrote Arrested Development. How do I get their ID? Well, let me select the person ID from the writers table, where the show ID is equal to, and now I need the show ID for Arrested Development. So now here's where I literally just take this first query from up above, select ID from shows where title equals Arrested Development. And I want to put that in here now. And so I would say select ID from shows where title equals Arrested Development. So that, a much more complex query, but really it's just these 3 queries combined into one. That gives you the same answer. Again, either way is totally fine. If doing things in separate queries makes more sense to you, then do things in separate queries. If you'd like to nest things together, you can absolutely feel free to do that too, but it is a little bit more complicated. All right, the last question we had for you. What are the shows that Alice and Jania starred in? How would we answer that question? Yeah, I see a lot of ways people could have done it. I'm seeing some really great queries. Really well done to everyone. So I'll first do this in separate steps if you prefer the separate step method, and then I'll show you how you would nest it together. So first of all, we need to know more information about Alice and Jenny, like what's her ID. So let me select ID from people, where name equals Alice and Jenny. And that gives us her ID, 5049. Now I want to know what shows did she star in. So I can take her ID and get that information. let me select all of the show IDs from the stars table where the person ID column is equal to that number. And here are all of the show IDs. And now I could look all of these up one by one, but here it's going to be much more efficient just to nest the queries together, just because looking up each of these IDs one after another is going to really start to get tedious. So instead, I'm going to say, select the title from shows where the ID is in. Remember, I use in anytime I'm looking for one of a list of possible values. And here was the query that got me all of her show IDs. And that now gives me all of those shows. And of course, I could nest one more time if I wanted to get her ID here. So I'd have 3 layers of nesting. You would be welcome to do it that way too. I'll pause here for questions about these queries that we've run. Nima is asking for what search algorithm is SQL using as it's performing these queries. It depends a little bit, but one thing that can make these databases very efficient is that they have the ability to build what are called indexes on the data. And we're not going to get too much into that today because we're going to try and keep today relatively introductory. But these indexes are interesting data structures. They're tree-like data structures, if you're familiar with trees, that allow us to very efficiently search through those trees to find the information that we're looking for. Sravidya is asking, should we also check the writers table for this question? Yeah, if this actress had written any shows, we would want to separately check the writers table. In this case, what we really care about is shows that they starred in, and so we're okay just looking here. Imran is asking, what is the difference between equal sign and in? Equal sign will check if one value is equal to exactly one other value. So if I have one particular ID, I can say where person ID equals that ID, and we're only going to get that person. Sometimes, though, I don't have one single ID. I have a whole bunch of IDs that I care about looking up. For example, here, I have a whole list of show IDs. And here, I don't want to use equal sign because no ID is going to be equal to this whole thing. Equals usually just compares against a single value, like the first one. So I instead use in to say, as long as the show ID is in this list, that's the way to read it. It's in this list. It's one of these values. Then you'll be able to access it. Is 3 the maximum number of layers you could nest? No, you can nest continually. You can nest even more as much as you'd like to add more and more sophisticated queries. Yeah, if you're finding the nested queries a little bit tricky, totally okay. You're welcome to stick to just the individual shorter queries, and that will work just fine. You'll just, over time, as you start to get more comfortable, probably find that nesting queries will help to make your queries a little more efficient, save you a little bit of time. But if you feel more comfortable right now, just using single queries at a time and using that data afterwards, that is totally okay. And you're more than welcome to continue to do that. And you'll do that, in fact, in one final example that we have for you. We have a bit of a problem for you, a mystery that's arisen in the CS50 world that I'd like to get your help solving. And this mystery takes place in the nearby town of 50ville. It's a town I know very well. And in this town, we've had a bit of a problem. There's a rubber duck in the town, and the rubber duck has been stolen. The CS50 duck has been stolen. And the town of 50ville has called upon you all in today's seminar to help solve this mystery for us, to solve the mystery of the stolen duck. The authorities believe the duck was stolen, and then whoever the thief was, they took a flight out of town and they had the help of an accomplice. And your job that we're going to try and get started with today, that we're not necessarily going to finish solving the mystery today, we'll leave some of that as homework for you, is to figure out who the thief is, who stole the duck, what city the thief escaped to, and who the thief's accomplice was, who helped them escape. And so that is the information that you're going to try and figure out. And we're going to need some way of trying to solve the mystery. But we did give you some information that's going to help you out. We have a database for you, a database of just data from across the town that you can use to try and solve this mystery. So I'm going to send you the database now that you can use. In your IDE, go ahead and run this command, run wget, and then this URL, the URL for 50ville.db. Again, it's in the chat, wget followed by that URL. And I'll also put the URL. I'll share the URL here so you can see it too. Here is the URL for the 50vil database if you'd like to download that. Again, if you're in the IDE, you can just say wget followed by the URL itself, and that will give you access to the database. And in a moment, I'll explore this database with you to give you an opportunity to try it out. But for now, let me give you well, actually, let's go here first and explore the database a little bit, and then we'll talk about what's going on. If you're inside a database already and you want to exit out of a database, like you're inside the shows.db database, Control-C, if you type it on the keyboard, that will exit the database you're currently in and just take you back to the regular terminal prompt. Here's where you can now type wget if you want to download the database. I've already downloaded it. So now what I'm going to do is run SQL IDE 50vil.db. This is a much smaller file, by the way, so you should be able to download it more easily and just upload it directly to the IDE. SQL IDE 50vil.db. Here's a database of all the information we've collected from around town that we're giving to you to help you solve this mystery. And remember that when you're in a database, I can type .schema to understand how this database is structured. So .schema, that's going to give me a whole bunch of tables. And there's a lot of information. Let's just focus on this very first table for now. You can, later on, you're probably going to want to explore the other tables to see what's there. But in this database, we have one table called crime scene reports. Every crime scene report has an ID. Every crime scene report has a year. Every crime scene report has a month and a day. Every crime scene report also has a street. On what street did that crime take place? And then a description of what it is that happened according to the police's crime scene report. So we have this table, and you can look at the other tables down below to be able to see the other information that you have access to inside of this database. And now here is the information that we're going to give you. The duck's been stolen. All you know is that the theft took place on July 28th and that it took place on Chamberlain Street. So I'm going to give you those two pieces of information. This is all we know. The CS50 duck was stolen on July 28th. The duck was stolen on Chamberlain Street. What year? 2020. It was last year. I'll tell you it was 2020. And your task for now, I'm going to give you 15 minutes or so to try to do this. You might not be able to figure out exactly who the thief is, but come up with a list of suspects. And that list shouldn't be any longer than 8, maybe a maximum of 8 suspects. But your job is to try and come up with a list of suspects. And the way you're going to do that is by looking at the database, studying the schema of the database. What tables do you have? What are the columns on those tables? And what information can you try and figure out by looking at that information? And so remember, we do have this crime scene reports table. Let me show you what happens if I try and select from the crime scene reports table. I'll do select star from crime scene reports. And I'll do limit 5, just to limit myself to a couple examples. And here we see a couple of crime scene reports. These are taking place on like January 1st and one on January 2nd. These are happening on a whole bunch of different streets. And each one has a little bit of a description as to what happened for that particular crime. So one place you might want to start is by looking in this crime scene reports table, trying to find the crime that took place on July 28th on Chamberlain Street, and use that as a place to start. Use that as a place to start as you start trying to figure out what happened. So again, the link to the database has been posted into the chat. This is the information that's been given to you. You don't know any information about the flight just yet, but in 15 minutes or so, see if you can come up with a list of suspects, a list no longer than 8 of names of people who are believed to be suspects. And then we'll talk about how it is that we might go about solving this mystery, helping out the authorities of 50vil in finding the stolen duck. So I will talk to you in 15 minutes. Again, if you have questions about anything, post into the chat, ask questions. You can use the course discussion forum as a place for asking questions too. And our team of mentors will be around to try to help you out. So 15 minutes to make some progress on solving the mystery, and I will talk to you after that. All right. Welcome back, everyone. Hopefully you found that interesting, hopefully a little bit fun. Does anyone have a suspect list? List of possible suspects it could be. List of 10, list of 3. Yeah, there are different ways of trying to solve the mystery, so it's not immediately going to be obvious. I'll help you out a little bit, thinking about places where you might want to get started. And seeing a bunch of different names. People are drawing conclusions. I see multiple people suggesting different names, and so we're not entirely sure who it is. Someone says, I'm the suspect. Okay, let's give this a try. Let's find out what might be going on here. Anyone want to tell me what query they ran first? Where did you start in trying to solve this problem? I'm not going to give away the entire solution. Don't worry. I'll just get you started, and then we'll leave it as a little bit of homework for you to try getting further. All right, so I like Harish saying he's selecting from the crime scene reports, looking for a crime that happened on July 28th on Chamberlain Street. So let's start with that. So remember that if I select star from crime scene reports and limit to just 2 results, just so we see it very quickly, these are the columns that I get: ID, year, month, day, street, and description. So let me now select star from crime scene reports, where the month is 7, and the day is 28, and the street is Chamberlain Street. So that's the month and day that we know. That's the street that we know. And we can see there's only one crime scene report from that day on Chamberlain Street. It says theft of the CS50 duct took place at 10:15 a.m. at the Chamberlain Street courthouse. Interviews were conducted today with 3 witnesses who were present at the time. Each of their interview transcripts mentions the courthouse. So we've got some information. We know there are 3 interviews with some witnesses. And we know that the interviews took place today, July 28th, the day that the crime scene report was filed. And we also know that somewhere in the transcript of the interview, they mention the courthouse, which is where we know that the theft took place. So what does the interviews table look like? Let's do select star from interviews and limit ourselves to 3 results, just so we can see kind of what the interviews table looks like. Looks like every interview has a year, a month, a day, and a transcript. So let's give this a try. We know those are the columns. Let me now select star from interviews, where month equals 7 and day equals 28. And you might remember I can say, and transcript is like, and then use the % sign as a wildcard there. Remember before when we were looking for all television shows that mentioned the Titanic, we used the same thing, like, and then these % signs. This is the same kind of idea. We're matching for a pattern. The transcript is not literally the word courthouse, but somewhere in the transcript is the word courthouse. And so that query might allow us to make a little bit of progress. Let's see what we get. All right, I see 3 interviews. I see an interview with Ruth, I see an interview with Eugene, and an interview with Raymond, each of which is trying to give us a little bit of information. So let's start with Ruth's interview transcript. We can get to the other ones a little bit later. But Ruth is saying sometime within 10 minutes of the theft. Anyone remember what time did the theft happen? I think it was in the crime scene report. What time did the theft happen? 10:15 a.m. Great, thank you. So sometime within 10 minutes of the theft, sometime between 10:15 and 10:25, Ruth saw the thief get into a car in the courthouse parking lot and drive away. If you have security footage from the courthouse parking lot, you might want to look for cars that left the parking lot in that time frame. We can use schema for those who are asking. Schema is another way where you can just see what the tables look like and what the columns are. Anyone see any tables in the schema that might be helpful to us here? Any tables in this schema that could be helpful? The courthouse security logs. Great. We've got one table of courthouse security logs. And we know that whoever the thief was left within 10 minutes of the theft. So sometime between 10:15 and 10:25. Let me just see what the courthouse security logs table looks like. Let me select star from courthouse security logs and limit myself to 3 results just to see a couple. All right, so this is what we're dealing with. We're dealing with, we got years and months and days. We have Oh, the hour and minute, 7:01, 7:31, 7:58. We have entrance. I'm assuming we also have an exit. Let me select like 20 rows. These are all entrances. Let's select 100 rows. Just experimenting, just exploring. All right, so yeah, we do have exit. So we can have an activity of exit that tells us someone's exiting. And Rahul is suggesting let's find their license plates. That seems like a good thing to do. If we know they left within 10 minutes of the theft, and we keep the courthouse security logs are keeping track of all their license plates, we might be able to do something here. So let's try something. Let's select license plate from courthouse security logs. That's the table. Where and what are our conditions? What are we going to filter on? Anyone have ideas on what we can do here? Oh, thank you for catching my typo. I spelled license plate wrong. That'll be a problem a little later. Let me fix that. All right, I like the suggestions where year equals 2020 and month equals 7 and day equals 28. And what do we do about the time? Yeah, between 10:15 and 10:25. So the hour must be 10. And actually, I'll put this onto a new line just so you can see it a little bit more easily. So and day equals 28 and hour equals 10. And yeah, I like the suggestion. And minute is greater than or equal to 15, and minute is less than or equal to 25. So we're chaining a lot of different filters together, but you know, there's a lot of courthouse security logs. There's a lot of rows. So we really just want the ones that are between 10:15 and 10:25. So we're looking for year is 2020, month is July, day is 28, hour is 10, and the minute is greater than or equal to 15 and less than or equal to 25. And I like Nishiha's suggestion, which is let's also check for activity equals exit, because we're looking for people that left at that time. And that feels like a pretty good list. Let's try it. And okay, we got 8 license plates. 8 license plates of the people that happened to leave the courthouse at that time. We're making some progress here. Thomas is asking, could we chain and even more? Yeah, you can. You can add as many ands as you want to keep adding additional filtering criteria to your select query. We have a whole bunch here already. We could certainly have done more. All right, so we got a bunch of license plates. What do we do now? What do we do with all these license plates? Anyone have a thought? Maybe if you've looked at the schema, progress we can make here. The people table. People are suggesting the people table. Michael's saying we can use that to find the owners of those cars. So let's give it a try. I'll type .schema. Let's look at the people table. Here's the people table. We got people's names, their phone numbers, their passport numbers. But all right, here, we got their license plate number. So somewhere in the people table, we're storing a license plate number for these people. So I'm now going to nest the query we just wrote inside of another query. It's going to be a bit of a long query. I like the way Michael's framed it. It's select star from people where license plate is one of those license plates. And so we're going to need to look for all those license plates. So I can say, for example, let's select name from people where license plate is in. And then I'm just going to duplicate the query that I just wrote a moment ago. Select license plate from courthouse security logs where month equals 7 and day equals 28. And hour equals 10, and minute is greater than 15, and minute is less than or equal to 25, and activity equals exit. So it's a long query, probably one of the longest we've written so far. But this innermost query inside of the parentheses, oh, and I could add the year too if I wanted to, and year equals 2020. Thank you for that. The innermost query is getting me all of those license plates. And then the outer query, this top line, is just get me the names of the people who have any of those license plates. And I'll press return, and we have a suspect list. We have the names of 8 people that left the courthouse at around that time. And I'm going to stop here with this particular mystery. If you'd like to try and solve this mystery, you might want to figure out how you could narrow down on that suspect list even further. And I bet there's other information from those interviews that might be able to help you with that. All right, but before we wrap up today's session on SQL, as I've mentioned and alluded to a little bit, I'm glad you're finding it fun, and to those of you who are mentioning that in the comments, a couple of you. We do have a little bit of homework for you. If you'd try a little bit more, if you'd like to try a little more SQL yourself. The first one is all about movies. So you can download this database either by going to the slides or by going to the seminar's website. You can find the movies.db database. It's very similar to the TV shows database, also from IMDb, but the structure is a little bit different. So you'll need to study the structure and write some SQL queries to answer these questions. What are the titles of movies released in 2008? What year was Emma Stone born in? How many movies have an IMDb rating of 10? What are the titles and release years of all the Harry Potter movies in order? And for Harry Potter, you can just assume that if the title of the movie has the words Harry Potter in it, that's going to be a Harry Potter movie. Who starred in Toy Story? That's another question. And finally, what are the movies in which Johnny Depp and Helena Bonham Carter both starred? So some questions to answer based on movies. And then your second homework assignment, if you'd like to continue this challenge, is to finish solving the 50ville mystery for us. Discover who the thief is. We narrowed it down to a list of 8 possible suspects. We think the thief is probably one of them, but could you figure out for us who the thief is? Also figure out what city the thief escaped to. The authorities think that he escaped out of 50ville. Where in the world did the thief go? And the thief also had an accomplice, someone who helped them escape. So if you could for us, figure out who the accomplice is to. So you've got the database, you've got the tools that you need to try and solve this problem, and that's going to be the second of your homework assignments for SQL. A lot of the SQL syntax I know is new. I know some people were having some trouble, particularly with the nested queries. Not to worry, it's the kind of thing that really just comes with practice. Goal of today was really just to give you a taste of the language, give you a sense for what it's all about and what it is that you can do with it. But before we wrap up, a couple last things. One, just a reminder, there are other seminars that are coming up later this month and next month. After the SQL seminars are over, Kareem from our team will be leading a seminar on Linux, and then Colton will be leading a seminar on game development. So if either of those are topics that you're interested in, we would encourage you to attend those, and we hope to see you with those too. And finally, before you leave, we'd love if we could get some feedback on the seminar, things you enjoyed, and we use this feedback for improving future seminars. And so if you could go to this URL here, cs50.ly/feedback, I'll go ahead and share it on this slide too. It shouldn't take very long to fill out, but we would love to get some feedback from you about what you thought of today's seminar. And once you fill that out, that will officially mark the conclusion of today's seminar. So please do fill out that feedback form. And thank you all so much for joining us at today's seminar. And a special thank you to all of our volunteer mentors who have been helping today in the chat and on Ed. If you have questions as you go through the homework assignments, feel free to post those on Ed as well. And the mentors will be around in order to help you to answer those questions too. You can continue to use that discussion forum even after the end of the seminar. So we hope you enjoyed today's seminar on SQL. Best of luck solving the mystery. We hope you're able to solve it for us. And we hope to see you at a future seminar. Thank you so much.